Okay, so we're going to continue today's lesson on circles to begin with. Okay, so that's why I've said circles part 2. And we're going to start off by looking at 30. Now, 26 through 30 is equations of circles with inequality signs rather than equal signs. All right, so if you remember with inequality signs, if the inequality sign is less than or greater than strictly, then you're looking at a dotted line. And if it is less than or equal to or greater than or equal to, then you're looking at a solid line. Okay, so for 30, they give us the equation x squared plus y squared plus 4x minus 10y has to be less than 7. And what we need to do is we need to figure out what the equation of our circle actually is. So we need to reorganize it just like we did in the last lesson over the weekend to get all the x's next to each other and all the y's next to each other. So this ends up being x squared plus 4x plus y squared plus 10y is less than 7. And then we complete the square twice. So we've got x plus 2 quantity squared plus y squared minus 10y less than 7 plus 4. And then we complete the square for the y, so that's going to be y minus 5 squared less than 11 plus 25. So the equation of our circle is x plus 2 squared plus y minus 5 squared less than 36. This means our center is negative 2, 5, and our radius is 6. So we're going to graph our circle like we normally would to begin with. So first we're going to plot our center, and then we're going to figure out how long our radius is going to look on the graph. So negative 2 is here, and 5 is up. So we're going to end up plotting negative 2, 5, right there. And then our radius is 6. So that means we're going to go all the way up to 11 on the y and all the way down to negative 1 here. And I run out of room here, so I'm going to go up there. And then we move to the right 6, so that's going to put us at 4. And to the left 6, that's going to put us at negative 8. And then, because our inequality sign does not include an equal sign, we're looking at dashed lines for our circle. So it's going to look like this. Now, what I suggest that would make this much easier than what I just did is draw the solid line and then erase the line pieces so that you can create that dashed look. So if you want to know what I'm trying to say here is, if I erase all that. So connect your circle. Again, I apologize for the terribleness of the circle. And then erase little pieces. Okay. It's a little hard to do here because I can't get a smaller eraser, but like so. Okay, and that line, that dash portion looks a lot better in some respects than the other ones do. And then the last piece is to shade. Now it says that we are less than 36, so we're going to shade everything inside our circle. So I'm going to change colors, and we're going to color in everything inside the circle. Okay, and that's it. Let's now move on to still finding the equation of a circle. Okay, so 32, we want to find the equation of our circle given the equation as you see on the screen. Now the slight problem is that up until now, all of our equations have had a constant of 1 in front of the x squared and y squared, and these don't. So the first thing we're going to do is divide everything by 9, or as I write it in the notes, multiply it by 1/9. Okay, so when we divide everything by 9, we end up with x squared plus y squared plus 6 over 9x plus 2y plus 1 is equal to 0. Now that the constant in front of our x squared and y squared are 1, we can now do the complete the square and everything else we've done before. So I'm going to reorganize into x squared plus 2/3 plus y squared plus 2y is equal to negative 1. And then I'm going to complete the square of my x. That's going to be x plus 1/3 squared plus y squared plus 2y, negative 1 plus 1/9. If you're wondering how I got the 1/3, 2/3 divided by 2 is the same thing as 2/3 times 1/2, so the 2's end up canceling out. And then now I'm going to complete the square of my y, so that's going to be y plus 1 squared equals negative 1 plus 1/9 plus 1. So I get x plus 1/3 squared plus y plus 1 squared equals 1/9. So that means my center is negative 1/3, negative 1, and my radius is 1/3. Now that we've done the center and radius portion and we've just worked with coefficients other than 1 in front of x squared and y squared, let's move on to where they give us pieces of our circle and they ask us to find the rest of the circle, as in they want us to find the equation. Okay, and with these, occasionally, and I think most of the time in my opinion, it's going to be beneficial if you graph the pieces they give you so you can figure out where the circle is going to land. So let's start off by looking at 38. 38 says that the center is in quadrant 2, the radius is equal to 3, and the circle is tangent to the y-axis at 0, 4. Now, quick vocab, tangent means that it's touching at that point, okay? So we're going to be touching the point 0, 4 on the curve itself. And then center in quadrant 2. Now, if you don't remember this, quadrants, that's the name of each piece of our coordinate axes, okay? So if you look at the bottom of the screen, I've got a coordinate axis here. This is quadrant 4, this is quadrant 1, 2, and 3, okay? And it's going to be important to memorize these because we're going to use them a lot from here on out. So the center of our circle has to be in quadrant 2. That would be here. The radius has to be equal to 3, and the curve has to contain the point 0, 4, and it has to be on the y-axis that way. So we're going to first plot the point 0, 4, right there, okay? And then since that point has to be on the curve itself, that means that it is got to be have the distance 3 from the center, okay? So that means that from 0, 4 to center is distance equal to 3. Now that just so happens to be our radius, and that's why we know it's 3, okay? So knowing this, we're going to move 3 to the left of 0, 4. So we're going to go 1, 2, 3, right there. And that second point has to be our center. Otherwise, this point 0, 4 is not on the curve, okay? So we now just figured out our center, and we can use the knowledge of the radius being 3 to figure out the rest of what the circle looks like. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So this right here is our circle. So now that we know that, we can figure out the equation of the circle just by knowing this. We know the center has to be negative 3, 4. That's what this point is right here, okay? And that our radius is equal to 3. So plugging into our known equation for a circle, we have x plus 3 squared plus y minus 4 squared is equal to 9. And that's the equation of our circle. Now let's try one that's a little more difficult, okay? So in 42, it says that the circle is tangent to both coordinate axes and the line x equals negative 8. So don't confuse that with the center's on the line x equals negative 8, which is in a previous problem, okay? It's it's tangent to the line y equals negative 8. So if we look down at the coordinate axes I have down at the bottom here, okay, we have to be tangent to x equals negative 8, which I'm drawing as a dotted line, okay, and each coordinate axis, so this one and this one. Sorry for my not straight lines, okay? So knowing this, that means we're going to have two potential answers, because we can have a circle in quadrant 2, and we can have a circle in quadrant 3. All right, and they would both align with the two mandatory pieces that we've been given. Okay, so the way to figure this out is that if it has to be tangent to x equals -8 and the y-axis, then we can use that as a way to find the total distance or diameter of our circle. So we're going to pick a point randomly on our circle. And the point on the line y, x equals -8, and the point I picked was x equals 4, and that's because it's halfway, it's 4 above the x-axis, and then, okay, so now that I've picked a point on the line x equals -8, I need to pick a point on the line, on the y-axis itself, that's going to be at the same height as the one on x equals -8, so I'm going to pick 0, 4 right there, okay? And so then these 2 points can be connected by a line that would be equal to the diameter of our circle. And what that tells me is that my center has to be evenly in the middle of them, right? Because the diameter is cut into 2 to make the radius. So my center for this top circle has to be -4, 4. Otherwise, these 2 points are not equidistant from each other is not equidistant from the center. And so my first center has to be, for my first circle, has to be -4, 4. Now knowing that, that means the radius has to be 4. Okay, and if the radius is 4, that means that I can draw the rest of my circle as seen now. And look at that, it's touching both coordinate axes, once here at 0, 4, and then once at -4, 0, and then it's also tangent to x equals -8. So my first circle, which I named C1, okay, is x plus 4 squared plus y minus 4 squared equals 16. And now the second circle is really just a reflection of the first one. So that means that the point I could pick to be on the line x equals -8 would be -8, -4. And so then the point that I pick on the y-axis is 0, -4. And so that means that my center is going to be -4, -4. And so then the rest of my circle can be filled in just like it did before. Like so. Okay? And so, knowing this, my second circle is x plus 4 squared plus y plus 4 squared equals 16. Okay? Now let's move on to 44. In 44, we're given the equation y equals -√25 minus x squared. Okay? First thing you need to know, as soon as you see this square root right here, you know you're dealing with a semicircle. And that's important, okay? So as soon as you see that square root and you see that it's got an x squared underneath, it's a semicircle. No doubt about it, okay? That's just a standard fact about this. The second thing you need to realize is that this negative right here tells me I only want half a circle where y is negative. Okay, I don't want any other piece of the circle. I only want where y is negative. So that tells me I'm going to look at the bottom half. That's what I'm going to end up graphing. Now the only problem is, how do I figure out what my radius is and my center is? And the quick fix to that is to square both sides. So if we square both sides, we get y squared equals 25 minus x squared. And then if we add x squared to both sides, we now end up with the equation of a circle. Okay? But remember, this is the entire circle. It's not half of the circle, and we only want half. So our center is 0, 0, and our radius is 5. But instead of graphing the entire circle, we only want where y is negative. And so if our center is 0, 0, we only want the portion with y negative, so we want to go down 5 on the x-axis, to the right 5 on the down 5 on the y-axis, to the right 5 on the x-axis, and to the right 5 on the x-axis, to the left on the x-axis. That's it. We don't want to plot that fourth point above the x-axis because we only want where y is negative. And that happens to be beneath the x-axis on this one. So our semicircle looks like that. And that's our graph. Okay? Now let's move on from circles, okay? No more circles for right now. Instead, we're going to look at parabolas. Now, parabolas should seem pretty familiar. We did do a lot of that at the end of the second quarter, okay? So really, the important things to highlight is two new terms that we're bringing in, namely the focus and the directrix. Now, the focus and the directrix are ways to help us graph and figure out the equation of parabola that aren't as cumbersome as it was in second quarter, if you remember how we did those on test 10. So, the important thing to know about the focus and the directrix is that the vertex is halfway, or midway as the book writes it, between focus and directrix. So it's the midpoint between the two of them, okay? And that's important to note. Also, the directrix is a fixed line that is perpendicular to the axis of the symmetry. And the focus is on the axis symmetry. Okay? Now, the next piece that you see on the screen in front of you is very important. We will be using all of these important facts about parabolas throughout these entire homework. So you need to memorize them and be able to manipulate them pretty quickly, okay? So the first one we're going to look at is our standard parabola, okay? Where y minus k is equal to a times x minus h quantity squared. Now, I will usually write mine as y equals a x minus h squared plus k, because I'm a creature of habit, and I can't break it as much as I want to try, okay? So if it's a y equals, like it is here, that means we are going to have a vertical parabola that either opens up or down. If a is greater than 0, opens up. If a is less than 0, opens down. Okay, and a formula for A is given in terms of C, which we use to find the focus and the directrix, both of which formulas are written below. Focus is a point, h, comma, k plus c, okay, so it's the y coordinate of the vertex plus some c, and then the directrix is y equals k minus c. So c is the distance between vertex and either the focus or the directrix, because they had to be equidistant from the vertex. And the axis symmetry, which you should know from last time, is x equals h, and the vertex is hk. Okay? The new one you might not have seen as much last time is x minus h equals a times y minus k squared. All right, the biggest difference here is that now we're no longer opening up or down. Instead, our parabola opens right or left. And it opens right when a is greater than 0 and opens left when a is less than 0. Okay, so now the parabola is turned on its side. So if you see x equals, that means you're looking at a sideways parabola. And again, I will more than likely write the equation as x equals a y minus k squared plus h, okay? The vertex is exactly the same as it is for a y equals parabola, and the axis symmetry, instead of being x equals h, will now be y equals k, okay? The directrix is x equals h minus c, so instead of being a horizontal line like it was before, it's now a vertical line. And the focus is a point where you add c to the h term, no longer the k. Okay, so those important things just you need to know, like it's a need to know, it's not an option, okay? So let's start looking at some of the problems. In number 2, they give us the directrix, which is y equals 2, and the vertex 2, 4, and they want us to find the focus, okay? So 2, 4, and 6, they give us 2 out of those 3 pieces, and they want us to find the third. So in order to help us figure out what each of these pieces are telling me, I'm going to quickly graph. I didn't put a coordinate axes here because I figured this was a bit simpler. Okay, and they told us the directrix is y equals 2, so we'll draw that there. And then the vertex is 2, 4, so 2, 4. The focus has to be equidistant from the vertex as the directrix is. So if the directrix is 2 below, as it is here, then the focus has to be 2 above. So the focus is at the y coordinate 6 and the x coordinate 2. That's it. You're done. Okay? So it's relatively simple. So it's nice that they are so intertwined as they are in their definitions. Let's look at one a little more challenging. In 8, they give us the focus and the directrix, and they want us to figure out the equation of the parabola just from those two pieces, and then graph it. And you'll be surprised it's actually not that difficult. And the reason why it's not difficult is if you remember from the lesson on midpoint and distance, we found that perpendicular bisectors, we can find them pretty easily. And the same thing goes for directrix and focus and the parabola equation. So the important thing to note is that if I wanted a point xy that is on the parabola, right, then that only works if and only if, that's what IFF means, if and only if the distance between the point and the directrix is equal to the distance between the point and the focus, where P to D is the perpendicular distance from P to the directrix, okay? And this is an important fact to use because we can use that PD equals PF to solve for our equation of parabola. So PD is equal to PF, where P is XY. Now the directrix they gave us is in form of a line. But if the point is XY, then the directrix has to be the point 4Y because it has to be equidistant. So the Y terms need to be the same. So we're going to do square root using distance formula to figure out this distance of x minus 4 squared plus y minus y squared. And that has to be equal to the distance formula of PF. So that's going to be using the same values for P, so that's xy. And then this time, we're going to plug in the point of the focus. That's x minus 0 squared plus y minus 0 squared. Okay, now y minus y is going to be 0. So this one right here goes to 0. And then I'm going to square both sides to get rid of those radicals. So I get x minus 4 squared is equal to x minus 0 squared plus y minus 0 squared, which is the same thing as x squared plus y squared. Now, this doesn't look anything like a parabola, right? So we have to figure out how to get it to look like a parabola. So I'm going to FOIL out what's on the left. So that's going to be x squared minus 8x plus 16 equals x squared plus y squared. And I'm going to subtract x squared from both sides. So I'm left with negative 8x plus 16 is equal to y squared. Starting to look a little more like a parabola now. Okay. And then I'm going to factor out a negative 8. And divide everything by 8. So I get x minus, that's not an 8 there. So I get x minus 2 is equal to 1/8 y squared, a negative 1/8 y squared. Okay. And then to make it look like how I normally would like to see a parabola, x is equal to negative 1/8 y squared plus 2. So this tells me my vertex is 2, 0, because h is 2 and k is 0. And I know my focus is 0, 0, so I'm going to plot what I know. So 0, 0 for focus, 2, 0 for vertex, and then the directrix was x equals 4. So like so. Okay, now that I've plotted everything, I can graph it. What might be beneficial is if you want to do a t-chart for certain values of the parabola, that's completely fine. So like, for example, I would test for where y is 0, plug it into the formula I have, and I get 2, and then test for where x is 0. So that's going to be -2 times -8, so that's 16, 4, and -4. And then I'm going to graph. And there you go. Okay. Let's look at a couple other examples of this. Okay, this time they gave us the vertex and the directrix. And then because the directrix is a y equals line, that tells me I'm looking at a y equals parabola. So I'm going to use the equation y minus k is equal to ax minus h squared. Okay, now I know what h is, I know what k is. I have no idea what a is. Because I know a has to be equal to 1 over 4c, I need to figure out what c is. And the way to do that is to use the number we got for the directrix. We know the directrix is y equals -4. And we know from the very first piece of this lesson that the formula for directrix in this case is y equals k minus c. So set them equal to each other. K minus c has to be equal to -4. So, and we know k is 0. So c has to be equal to 4. Knowing this, that means that a is equal to 1 over 16 when we plug c back in. Okay? So now I can figure out my equation. I get y minus 0 equals 1/16 x minus 0 squared. Or y equals 1 over 16 x squared. From there, I can graph. So I know that my vertex is 0, 0. And then my directrix is y equals -4. So that's down here. Okay. And then, since c is 4, that means my focus has to be 4, 0. Okay. So my graph will look something like this. Now I would actually make it a little fatter on the right side. There we go. Okay. Now let's look at 16. 16, they gave us the focus in the vertex rather than the directrix in the vertex. Okay. So knowing that the vertex is -3, 1, and the focus is -2, 1, I see that the k coordinate or the y coordinate is the same, right? They're both 1. So that tells me I'm looking at a parabola x equals. And the reason why I know that is because if you look at the formulas I gave you at the very beginning or in your notes, focus is h plus c comma k, and vertex is always hk when the parabola is x minus h equals a y minus k squared. Okay? So again, just like with the last problem, I know what my h is, I know what my k is, but I still don't know what my a is. So we need to figure out what a is, knowing that a is equal to 1 over 4c. In order to figure that out, I need to solve for c using the knowledge that I have about the focus. So since focus is equal to h plus c comma k, and we know that the focus is -2, 1, that means that h plus c has to be equal to -2, and h is -3, so -3 plus c has to be equal to -2, so c has to be equal to 1. Using that, I'm going to plug that back into my a formula, so I get that a has to be 1/4. So the equation of my parabola is going to be x minus minus a -3 is equal to a times y minus 1 squared. and then plug in my a, so I get x plus 3 is equal to 1/4 y minus 1 squared, and then I rewrite this to be x equals 1/4 times y minus 1 squared minus 3. And now all I gotta do is graph this thing. So I'm gonna plot my vertex first, that's -3, 1. My focus is -2, 1. And since c is equal to 1, that means my directrix is the line x equals -4. Like so. Okay, so, and then I just need to figure out a couple values. Like I want to know where does it cross the x-axis and where does it cross the y-axis. So I'm going to plug in 0 for x, and I end up with a really nasty number. It ends up being square root of 12 plus 1. I don't like that number, so I'm probably not going to graph it. And then plug in, plus or minus 12, square root of 12 plus 1. And then I'm going to plug in 0 for y, and I get 1/4 minus 3, which is -11/4. So it's a little less than 3, so it's about there. Okay, and I'm just going to graph. Since parabolas are symmetric, you need to make sure that you try and draw them as symmetrical as possible. Okay? Okay. Now let's look at 20 and 22. In 20 and 22, they gave us the equation of a parabola. Sometimes it looks like the standard, sometimes it doesn't, okay? And they want us to find the vertex, the focus, the directrix, and the axes, and then graph and label all of that. All right, so looking at 20, we have x squared equals y plus 2x. This doesn't look like the standard equation, so what I'm going to do is subtract 2x from each side. Okay, and I know that it's not completely done yet, right? So I need to complete the square. So when I complete the square, I get x minus 1 squared equals y plus 1. This looks very similar to my standard equation for my parabola that's vertical. So I have that x minus y squared is equal to, minus 1 is equal to y. So my vertex is going to be 1, -1. My focus is h comma k plus c, and the only thing I'm missing is the c. Now I know that a is equal to 1, right? So I can set that equal to our formula for a, which is 1/4c, and solve for c. So 4c is equal to 1, c is equal to 1/4. So the focus is going to be 1, -1 plus 1/4, which is 1, -3/4. The directrix is going to be y equals k minus c, or -1 minus 1/4, which will be -5/4. And the axis of symmetry is x equals 1. So now that I have all the information I need, I'm going to graph each of these pieces of information. So vertex first, 1, -1. Focus is 1, -3/4. So that's going to be about there. It's a little high, but that's okay. And then the directrix is going to be y equals -5/4. So that's going to be right underneath that. And then my axis of symmetry is x equals 1, which I'm going to draw in a different color. Okay. So the next thing I got to do is graph this. So this is going to be if I plug in a couple of values, if x is 0, then y is 0. Okay. So it's also 2. And a graph. So there's my parabola. The only thing left to do is label each of these. So I have x equals 1. I'm going to label this with an F down there at the bottom, V next to the vertex, and then y equals negative 5/4 there underneath the directrix. Let's look at 22 now. For 22, it says y squared plus 6y plus 8x minus 7 is equal to 0. This, again, doesn't look like our standard equation, so we need to reorganize and complete the square. I'm going to subtract y squared and negative 6y from each side. So I get 8x minus 7 is equal to negative y squared minus 6y. So I'm going to factor out a negative. I get y squared plus 6y. And then I'm going to complete the square. So this is going to be negative y plus 3 squared. 3 squared is 9, multiplied by the outside, remember? So it's a minus 9 added to the other side. So I get 8x minus 16 is equal to negative y plus 3 squared. We're not done though, right? It has to be an x equals equation. So I need to divide both sides by 8. I get x minus 2 is equal to negative 1/8 y plus 3 squared. And then I'm going to move the 2 to the other side. So my vertex is 2, negative 3. My axis of symmetry is y equals negative 3. And the reason why it's y, not x, is because, again, this is an x equals. So remember all of those important facts I listed at the beginning. The focus is equal to h plus c, comma k. So I need to figure out what my c is. So a is equal to negative 1/8 and has to be equal to the formula 1 over 4c. So negative 4c is equal to 8. C is equal to negative 2. So I get 2 minus 2, comma k. Or 0, negative 3. And then the directrix is x equals h minus c, so x is equal to 2 minus a negative 2, or 2 plus 2, which is 4. Now that I have all the important information, I'm going to graph. I'm going to zoom in on this one so I can see it a little better. So my vertex was 2, negative 3, so I move up 2, over to the right 2, up, down, negative 3. And then my focus was 0, negative 3, so I'm going to move over to the left 2. And then my directrix is x equals 4, so that's going to go to the right 2, like so. And then my axis of symmetry, which I'm going to draw in red, is y equals negative 3. Okay, I'm going to label each of these. So this is y equals negative 3, x equals 4, the point 2, negative 3, and the point 0, negative 3. And then I need to graph. Before I do that, again, I want to find a couple values first. So mainly the x and y intercept. So if I plug in 0 for x, I end up with y equals 1 or y equals negative 6 when I plug in 0 for x. So 1, negative 6. So I'm going to cross the y-axis. And then if I solve where y is equal to 0, x is equal to 7/8. So that's going to be a little bit in front of 1 on the x-axis. And now I'm ready to graph. Okay, and that's my parabola. Okay, so let's look at 30. In 30, we're given the equation x minus 11 is less than y squared plus 6y. So we're looking at parabola equations that are inequalities, just like we did with circles before. So the first thing I need to do is I need to get this into the standard form of a parabola. And in order to do that, I need to complete the square on the right side of my equation. So I have x minus 11 is less than y plus 3 quantity squared, and then I need to add 9 to the other side. So x minus 2 is less than y plus 3 quantity squared. So x is less than y plus 3 quantity squared plus 2. So now I know that my vertex is positive 2, negative 3, and I can graph. So I go to 2, negative 3 down here on my coordinate axes, and I want to figure out where is it going to cross the x-axis. So I'm going to plug in a value for y, namely 0, and solve. And I'm going to make this an equals, so I want x equals to 11 when y is 0. Okay? So I'm going to plot that point, and then I'm going to draw my parabola. Okay, now that I got my parabola, there's a slight issue, if you do notice that one. And that is, I have a strictly less than inequality sign, which means I cannot have a solid line. I have to have a dashed line. So I'm going to make these lines dashed as much as possible. And there we go. Now, the last thing to do is to shade. And it says that in 30, the equation has to be less than our parabola. X is less than our parabola. So if my shading is less than everything in my parabola, that means that I want to shade everything outside of my parabola. So that means all of this is what I shade in. Okay, and that's my answer. Let's now look at 34. In 34, it says y equals negative square root 3 minus x. So if you recall, we did work with square roots before, namely square roots that ended up being semicircles. Now these end up being half parabolas, and the reason why they end up being half parabolas is because if you look closely, instead of saying 3 minus x squared, they say 3 minus x. Okay, so that's the biggest difference between knowing you have half a parabola and half a semicircle. They both have square roots, but one has a square on the x, the other one does not. So if you see square root 3 minus x, or square root 4 minus x, or 2 minus x, you know you have half of a parabola. Okay, and then just like before, the sign in front tells us which half we want. And the sign here is negative, so we want where y is negative. Okay, and to figure out where exactly this parabola would normally land if we didn't have a square root, we're going to take the square of both sides. So we get y squared is equal to 3 minus x. And then we solve for x. So y squared minus 3 is equal to negative x, or negative y squared plus 3 is equal to x. Now this looks like the standard equation for a parabola on its side. And so then we need to figure out, is it opening left or opening right? A is less than 0 because it's negative 1, right? So opens left. And our vertex is 3, 0. So we're going to plot this. 3, 0. It opens left, and then we want to be negative for the y. So that means we're going to be below the x-axis, not above. Okay, so like so. And that's our equation. And that's the lesson. So the classwork is due on Thursday and Friday, and that's not a mistake, right? I know this form is due Tuesday night for everybody, but I want to give you guys time to really digest this lesson because I know that graphing is a bit of a struggle for some of us. So this homework is not due until Thursday for C block and Friday for F block, all right, at the end of class. You have roughly around an extra day or two to really let that lesson sink in and maybe even start the homework if you so choose. All right, and the classwork is page 410, numbers 25 through 45 odd, and page 415, numbers 1 through 33 odd. And both these lessons involve a lot of graphing. So if you want to use some graph paper for your graphs only, that's completely fine. You can do the work on one sheet and the graphs on another sheet. All right.